Hello, everyone. Very good morning and good evening. Welcome to the Oracle Database Training, Day 6. Today, we are going to discuss two important examples in the Oracle architecture, how architecture components behaves during a select statement, basically a DML operations, select and update. Okay. So when a select operation initiated by the client, what will happen internally in the database architecture, and when a update statement is passed by the client, what will happen inside the database architecture. We are going to see some examples and some live demo as well today. So before we get there, let's see some quiz questions so far what we have learned on the Oracle architecture. So based on that, I have prepared some questions for you people. It will create some refresher till at what we have discussed on the Oracle architecture. Yeah. Are you all ready? Just give a thumbs up if you're all ready. I will bring the quiz questions here. All right. Here you go. Yep. The first quiz question. Which of the following is not a component of the Oracle instance? A. System global area. B. Background processes. C. Data files. D. Program global area. Out of these options, which one is not a component of a Oracle instance?
C.
C. Okay. Who said that? Carl? Pride.
Yes.
Okay. Yeah. Carl mentioned option C would be the right answer. Anyone have a different answer with you?
No, second.
Okay. Danish also says C. Yes, C is the right answer. So remaining all options are like part of the memory and background processes. So system global area or shared global area is part of the memory structure. Background processes, you know, uh, background processes that runs on the Oracle instance when it started, and PGA. PGA is also memory structure is part of the memory program global area. It's absolutely right. C is correct answer. Data files is not part of the Oracle instance. Data files are part of the database, Oracle database. Okay, where actual data will be stored. The next question: what does the program global area (PGA) contain? Okay, so option A: shared information for all users accessing the database. Memory structure for recovery operations. Private data for a server process such as a short area and session information. The option D is the redo log files and archive logs. So which one is the right answer? So what does the PGA contain?
Option C.
Option C, Rahul said. Option C. Someone else is also speaking.
C is correct.
No.
Yeah, C is right. So whenever a server process is created, immediately a private global area or program global area will be allocated to that server process from the memory, and that's a dedicated private PGA. So that'll have a private data session information, and it'll also be used for the short operations, etc. So option C is correct. Option C is right answer. So let's move to the next question. So what is stored in the redo log buffer? Copies of data blocks for backup purpose, transactional change that needs to be written to the redo log file. C. Query results for faster access. D. User credentials and connection details. which information will be there in the redo log files?
B.
Okay,
B.
option B. Yes, option B is right answer. All the change vector information will be there in the redo log files. All the changes, previous copy and current change copy. So before the change, whatever the data blocks that information is having, that information along with changed information, both the information will be available in the redo logs. That's absolutely correct. And the fourth question, which process is responsible for instance recovery in case of failure? It could be a power failure or corruption, whatever, so which process will be responsible for instance recovery? Option A, DB writer. Option B, SMON. Option C, PMON. Option D, log writer.
I think it's Pimon.
B. I think it's B.
Any other? The right answer is SMON. So the right answer is SMON, because S1 will takes care of the instance recovery with the help of redo logs. Okay, with the help of redo logs. PMON is a process monitor which will takes care of the sessions. Looks at the session whether it is idle, whether it is disconnected. It clears those sessions, and at the same time, it will also register the database in the listener. PMON does that, but SMON is something will take care of the instance recovery part. Whenever there is a failure in the database, it could be a power failure, it could be a abrupt shutdown. S1 will come to the picture whenever you start the database freshly. So it will do the recovery process. It will do the roll forward, roll back for the committed and uncommitted transactions, and then bring your database with the consistency state. Let's see, one more time. Yes. Yeah. Responsibilities: instance recovery, roll forward, changes in redo, open database user access, roll back uncommitted transactions, collapses free space, reallocate temporary segments. So this is the purpose of the SMON. Let's see. Next question. So what is the role of the control file in Oracle database? A, it stores temporary query results. B, it keeps track of the database structure and transaction information. C, it contains user passwords and roles. And D, it manages external file storage. So which option is correct?
Track of database structure and run.
What is the role of control file in Oracle database? I told you, right? One of the
It's,
core
it's,
component it is.
it's B. Keep track of the database structure and transaction information.
Exactly. Yes. So it keeps track of all
Oh,
the database structure, and it'll have the redo log file location, data file location, and also checkpoint will update the SCN details in the control file header. So so that without a control file you cannot open the database. So to read the control file, what will the instance do? It will opens the control file before a database is opened. That state is called mount state. We saw yesterday, right? So different states: no mount, mount, and open. So these are the states while your database is opening up. So no mount is nothing but instance. Mount is nothing but opening your control file. So that control file will have all the key information of your Oracle database. So where your data file store, where your log file store, where your archive log file stored, all that information will be available along with the transaction information as well. So not the actual transaction, the SCN information, system change number information, which will help us to bring the database to a point and make sure the database is in a consistent state. Okay, so the right answer is option B. The next question: which component ensures that committed transactions are written to disk immediately?
A.
Yes, option A is straight away. Option A is right answer. Checkpoint. Checkpoint does writing the data to the disk, or no, it'll invokes the DB writer to write the data basically. Okay, invoke the DB writer to write the dirty buffers from the shared pool buffer, so not shared pool, buffer cache to the disk. Yeah, checkpoint is the right answer. The next question: what is the purpose of archive log mode in Oracle? What is the purpose of archive log mode in Oracle? A, to prevent users from accessing the database during the maintenance. B, to enable database recovery by keeping copies of filled redo logs. C, to store user profiles and setting. D, to optimize memory usage in large databases. So
I
which
think
option is
it's B.
Option B. B.
option B? Yes, exactly. All filled redo log information will be written to the archive logs, which means it is taking the backup copy of the read log files and keeping it for the future usage. Okay, permanently in the archive log. If it is not enabled, the read log file will be overwritten again and again. Okay, so the purpose of the archive log is to recover the database and make your database to a point in time. Okay, and it will be stored permanently also. The change information will be stored permanently in the archive log file. That log file will be used to do the backup and recovery when needed. Okay, the next question is: what is the primary function of the data dictionary in Oracle database? It's to store SQL queries for reuse, option A. Option B, to store metadata about database objects like tables, indexes, and users. Option C, to log all database errors. Option D, to manage disk storage allocation.
Option B.
Option B, yes. Option B is the right answer. So, data dictionary will be one of the component in the shared pool. Okay, shared pool will have two components: library cache and data dictionary. Library cache stores all the SQL queries for reuse. Okay, but data dictionary will have a metadata about database objects like tables, indexes, and users. Okay, that's right answer. Option B is right answer. And our question number 9: which memory structure stores past SQL statements in for reuse? Which memory structure? Just now we discussed about that.
A. Sorry, do log.
No, B.
It's B. It's B.
Yeah.
It's B. Which memory structure stores the SQL statements for reuse? Just now we spoke about, right?
Library.
Library cache. So that is part of the shared pool, right? So shared pool memory structure is the right answer. You getting?
Yes, yes.
Okay. The last question: what is the function of listener process in Oracle architecture? Option A, it monitors disk space and memory usage. Option B, it handles client connection request and directs them to the appropriate server process. Option C, it archives redo logs for recovery purpose. Option D, it updates data dictionary with changes.
It's B.
B.
Yeah, undoubtedly it's B. So listener process handles all your client requests and directs them to the appropriate server process. So the responsible file is listener.ora. Okay. So this listener plays a crucial role in facilitating communication between client and database server. Yeah. So basically this accepts the connection from a client and direct them to the database instance. So it will handle TCP IP protocols and port number and registration of your database. All this will be there in the listener. Okay. So basically service registration. Listener register the database service, make them discoverable for clients so that client can connect to which database they wanted to connect. Okay. So with that, I'll uh, going go back to the session. Okay. Till now, any questions you guys have before we get started today's session on uh, two examples, select and update.
Is it possible for us to have these questions so we can always use them to review?
Uh, Pardon me, can you repeat? Is it possible to?
Is it possible for us to have the questions you always ask before class so we can also review? I think it's really good.
Quiz questions?
The ones we just did, the ones we just went through, is it possible for you to always send it to us so we can review?
Yes. I will do that. Yeah,
Okay, thank you.
yeah. Quiz questions, right? Yeah, I will do that. And I
Yeah.
try to give you before in hand, like uh, if the session is today, I will give 1 day prior these questions to you people to think and uh, answer those questions. Okay, and then we
Okay.
can discuss in this before we start. Okay, that'll also be possible. Okay, good. That will create some refreshing in your memory as well, so that you will remember when you answer these questions. When you answer wrong or right, doesn't matter. If you are answering wrong, you will learn what is right. If you are answering right, you will register that permanently in your memory. Okay, so that's why I come up with this strategy to have questions and ensure that you guys familiarize more on these topics. That's the whole intent. Okay, so any other questions? I'm assuming I'm assuming that you're all clear on memory structures, background processes, and Oracle database physical and logical structures as well. If you have any questions, please open up, or I'll go to the example straight away. Okay, I'll take this silence as no. I'll go to the uh, content here. So if anytime if you have any questions, do let me know. We'll discuss about that. Okay. So let's look at
Sorry.
the
Sorry.
yeah, pride. Go ahead.
I have a question.
Uh,
Yeah. Can I go on?
yeah, go on.
Yeah, it's about the segments and the block
Hmm.
and the extents. So, yeah, data is primarily stored as blocks, right?
Yes.
So, once for you to get to the data,
Hmm.
you have to, let's say, the client sends a request.
Hmm.
So, it has to go through the segment, extend to the block. Is that how it travels? to
Mm.
query the data?
It's a storing structure basically. Okay.
Oh, okay, okay.
When a client requests for a data, it will directly go to the uh, you know uh, data blocks. Yeah, it eventually goes through all this table space, which table space the data is resides in. Then within the table space, which extends the table space data is having, and then segments like which segment and which extent, and then what are the data blocks that data actual data is available. Okay, so that's how it goes and reads the data and brings.
Okay.
Okay.
Because what I was thinking was like if you have a query
Mhm.
for your query to identify where the data is, it has to go through certain tracks to go pick out the table, right? Like
Yes.
how to optimize query and things like that. So I was thinking maybe is this a part or that is different?
That's a different. Now we will talk about that. We will talk about
Okay.
that in the select uh, example.
Okay, thank you.
Okay. I will talk about like parsing, all these things. Like an optimizer will also come into the picture. All these things. Okay. Yeah. Here you go. So today we'll talk about the Oracle architecture example, transaction example. Select. Okay. So yeah. So what will happen when a select query is triggered by the client? So we'll explain you guys step by step. Okay. So let's see. Where's my query? Okay. So a query is submitted by the client. That query is SQL star from employees. This is the query, SQL query that has been fired by the client. So immediately what will happen? A user process is created for that. Whenever you initiate a client connection, a user process is created for that connection. That user process will establish a connection to the server process. Okay. So how that establishment will happen? With the help of listener. Okay. So listener will help user process to communicate with the server process. Okay. Once user process started communicating with server process will be allocated with the PGA, program global area. A dedicated area will be allocated to the server process. Okay. Dedicated global area. So to have the session information, all this information will be there in the uh, cursor information, stack information, all information will be there in the PGA. Okay. Then the dedicated server will start, uh, and the session is created. Then it start communicating with the SGA. Okay. Immediately it connects with the SGA. Within that SGA, it will connect to the shared pool. Okay. This is important. So in a select query, the dedicated server process will communicate with the shared pool. Okay. So within that shared pool, it touches the library cache. Okay. Uh, Within shared pool, we have two components, library cache and dictionary cache. It first touches the library cache. Okay. So that library cache, it works on, you have given a select star from employees, right? It creates a work SQL area with a hash value for this query. Okay. Basically, it creates a SQL area for this query and a hash value also. Okay, hash value is a reference value. Okay, it is a reference value. We'll talk about how this reference value will be used. Okay, so what happened, it created a SQL area to store the SQL star from employees query, because you are running this query for the first time. Okay, so this case we are running a select star from employees for the first time. Okay, so when you are running for the first time, it creates a SQL area to store that SQL query along with a hash value. Hash value is nothing but a hexadecimal value, okay, for that query. So will be used for the referencing purpose. Okay, so then once this is done, what will happen, a parsing will be done. Okay, so parsing now, so in the parsing, what will happen, syntax checks what is the query is missing out, whether we have any keywords missing, or any spelling mistakes are there. The syntax check will perform those checks. Okay, and then semantic checks. Okay, semantic check will check the database object, whether that a particular table or column is existing or not, and the user that connects to or retrieves from that particular object is having privilege or not. So that will be checked by the semantic check. How? It again refers the data dictionary, because we all know data dictionary have the metadata, all the objects, table views, indexes, user roles, privileges information will be available in the data dictionary. Okay, so that will check, semantic check will check that, okay, from the data dictionary, whether that specific object is available or not, that user is having privilege or not to access that particular object. Okay, if if it is available, then goes to the next step. If it is not available, goes back to the user and say that uh, the object is does not exist, or you don't have a privilege. Okay, it ends, the process ends here, either as a syntax check or a semantic check. If the query fails, then this check is failing, then it immediately goes to the user process and say that there's a query error. Okay, so if it is success, semantics also right, okay, semantic check also done. Okay, what will happen, okay, then it goes to the shared pool check. Okay, so shared pool check, in this shared pool you will have all the hash values, okay, which created in the initially, right? So if this query is running for the first time, so it will check this hash value which was created in the SQL area, whether it is there in the shared pool check no component. Okay, if it is available, the hash value will have a reference execution plan. Since we are doing it for the first time, so the hash value won't be available in the shared pool check. Okay, but it checks as part of the parsing, it checks whether this SQL statement already executed in the past and it has the execution plan or not. Okay, okay, so it checked and it do not have the any execution plan. Okay, there is no match found. Okay, if a match found, uh, server process need not to generate any execution plan if a match found. But if no match found, then server process has to proceed with the generation of execution plan. So the next step is generation of execution plan. So how that execution plan will be generated, with the help of optimizer. Okay, the uh, process engine, we call it as optimizer. So optimizer will help to create the right execution plan. So it creates multiple execution plans basically. So optimizer will create execution plan, who will read the SQL statement and generates the execution plan of the query. So that this optimizer will generate multiple execution plans during parsing. Okay. Store procedure, server process will pick the best and cost effective executive plan out of multiple execution plan it created. Okay. So let's see. So optimizer will create the execution plan. Then the next step is execution. Who will execute? The server process will execute the best possible execution plan. Okay. And then it will also store that execution plan in the library cache along with the original SQL text. Okay. So this optimizer will create execution plans, multiple execution plans, and out of those multiple execution plan, the server process will decide which execution plan is best and optimized to run it in the SGA and get the data. Okay. So next, from the optimizer, execution plan is created, right? So what will happen? So the now entire process has happened, right? For the first time you are running. So this process, parsing and creating execution plan and moving that execution plan to execution, is called as a hard parsing. It's called as hard parsing because you are running this query for the first time in your SQL server, Oracle database. Okay. So that called hard parsing. Okay. So then what will happen? It moves to the execution. The server process will go to the database buffer cache. Okay. The server process will go to the database buffer cache during the execution and checks whether the data required by the query is already available or not in the cache. It checks this cache whether the data is available or not. Okay. First, whenever you fired a query, the server process will first check the database buffer cache. If it is available, it is easy, right? Get from the memory itself. It will reduce the IO on the disk if it is available in the memory. Okay. In this case, you're triggering this query for the first time, right? So the data won't be available in buffer cache. We never executed and kept the data blocks in the buffer cache. So uh, all the buffer cache are free or available for you to get the data from database files. Okay. So server process connects to the buffer cache first and checks whether the data blocks are available or not. Okay. If available, that can be returned to the client, else it bring from the database file and keep it in the database buffer cache. Okay. So the next step, what it does, okay, I don't have a database blocks available in the buffer cache. Okay, then it goes back to the database files. Okay, it reads the data. Okay, whatever the SQL star from query, like employee is asking for the data, it reads the data. Okay, and that data will be fetched back to the database buffer cache. Okay, so that data will be moved to the database buffer cache and written in the blocks. So those blocks are 8 KB. So database buffer cache is divided only in the blocks only. Okay, so those blocks will be moved to the database buffer cache. Okay, so here this information, whatever the database files have, that will be moved to the database buffer cache. Okay, so now let's see what will happen next. Before the next step, so here you have moved some data to the buffer cache, right? And you can see color also, it turned out pink. Okay, so that data is available in the buffer cache now. Okay, so now you are doing the process, so you're trying to access this data. So this data blocks, right, and a white data blocks you see, right? So each data block will have a different states. Okay, I'll talk about them also now. Different states, what are those different states? Okay, I'll talk about. So one is pinned. Okay, pinned state. So a session is using the buffer so it cannot be replaced or returned to disk. Okay, so now we are using this certain blocks, these three blocks, right? So until we complete this process, these blocks will be pinned. Okay, which means we cannot wipe it up, or we cannot remove them from this particular blocks until we complete entire this transaction. Okay, so that is called pinned. The next to pin, you see multiple white blocks, right? Those are all free. Okay, the buffers is idle and can be used to load new data from disk. Okay, from disk, if you wanted to load new data, you can use these free blocks. Okay, so right now you remember these two states, pinned and free. Okay, so in the update statement, I'll talk about dirty and clean also, another two states. So let's remember these two first. Okay, pinned and free. So pin, so the state will be in pin state until that particular transaction is completed. Once the transaction is completed, then the pin state will be moved to clean. Okay, so we'll talk about that now that the actual data is written here in the buffer cache. So what will happen, the next step, the next, the server process do the fetch. Okay, fetch from where? From the buffer cache to the dedicated server process, and from there to your user process, and the data will be retrieved here. Okay, and you will see all the rows that you have requested for. Okay, so this is the select statement. Okay, whenever you execute, it goes to the first shared pool. Within that shared pool, library cache will be there, and within that library cache, SQL area will be created for storing the SQL statement with a hash value. And then it goes to the parsing state. So parsing syntax, semantic, and shared pool check will happen. And then it moves to the optimizer will create multiple execution plans, and the server process will decide which execution plan is best and optimized one to choose. And then that will choose, and it goes to the execution. So when you are doing it for the first time, that process is called hard parsing. Okay, so the same thing, the same query, you're doing it again. Okay, select star from employees. What will happen now? Again, it goes to the library cache. Okay, then it goes to the SQL area with hash value. Okay, again a hash value is generated for it. Then now it will directly check the shared pool check. Okay, since you, it will do the semantic and syntax check again. Okay, and now it goes to the shared pool check. So it will find the reference hash value. Okay, it will create a hash value, right, for the SQL query. So it will have a match to that particular hash value. Then it immediately, along with that match, that hash value will have a reference execution plan as well. Okay, so that will be referenced with the execution plan. So immediately it finds the execution plan and go to the execution. It will not go to the optimizer. It need not to go through the optimizer, because this SQL query is already having an execution plan. Okay, this SQL query is having an execution plan. So it directly goes to the execution, and from the execution, it first checks the database server buffer cache. Okay, database buffer cache. Since the data is available in the buffer cache, it reads from the buffer cache and gives that data to the user. That's all. Okay, so that entire process is called soft parsing. Okay, so it need not to go through the execution plan in the soft parsing. Okay, soft parsing need not to go through the execution plan creation. Clear?
I have two questions.
Yep, go ahead.
Yeah, when you were explaining about the server process,
Mhm.
I think in the last class you mentioned passing, binding, execution, and fetch.
Mm.
Today, when you are explaining how the select function goes through, you didn't say anything about binding.
Uh, Binding is happening here. The listener process is coming, right? So that time the binding will happen. Okay, the connection is established to the server process from the user process, right? So that time binding will happen, with the help of PGA. That session will be recorded in the PGA. The session information will be available in the program global area. So that is binding. Okay. So the remaining parsing is happening here with the help of a server process only. Server process only, you know, uh, is the process will do the control and process of this shared pool memory. Okay. So whatever the shared pool memory structure we have, it controlled by the server process. So the parsing, it will be controlled by the server process. Optimizer, it will be controlled by the server process. Execution, it will be controlled by the server process. And fetch also, it will be controlled by the server process only.
Okay. My next question has to do with
Before you go to the next question, did I answer your question?
yeah, I just wanted to know exactly where binding is happening, because when you explain, when
Yeah,
you
yeah.
listed the
Different
processes,
states.
yes,
Yeah, different states I have explained in the
yeah,
server process. Yeah, correct.
okay.
Go ahead.
My next question had to do with hard passing. When you explained hard passing yesterday, you said when the server process goes into the shared pool and the data is not there, it has to go to the data file and retrieve the data
Yeah, that is discrete.
the
That
first
is
time.
discrete. That is discrete, not the hard parsing. Okay. Uh, you can call it as a discrete because at that time you will not have a data in the database buffer cache, and it goes to the data file and reads the information. That is called discrete.
Okay,
Okay.
thank you.
So that will happen with the hard parsing only, right? If you don't have an execution plan for the first time you're executing a query, it definitely has to go through the hard parsing and discrete because the data won't be available in the buffer cache when you're executing it for the first time. Okay, when you're executing for the first time, there won't be any execution plan also. It has to go through the hard parsing. It has to create an execution plan for it, and the server process should decide which execution plan should run in the database server and then get the data. But sometimes, like hard parsing will happen, but your data will be available in the buffer cache. Okay, you might write the query in different way, that SQL text different way and executing it, but some of the data blocks are available in the database buffer cache. At that time discrete won't happen, only hard parsing will happen. Did I clear your question?
Yes, yes.
Okay, so this is a select statement. Anyone have any doubts on it?
Should we see everything in action also? Like this is the SID, this is the plan hash, this is the execution plan, and
Yes,
all
yes.
live?
Yeah,
Okay,
yeah. I will show now
thank you.
the live demo.
Yeah.
So I will trigger the same query in the Oracle database server, and what will happen we'll see. Before we go to there, anybody have any questions? So all your library cache information you can see in the $V SQL. That is the view. Okay, data dictionary view. You can see the information of your SQL text, plan hash value, parse calls, loads. All this information you can see in the $V uh, SQL data dictionary. Okay, I'll show you guys what that information is all about and how you can identify with the practical session. Okay, so before we move there, anybody have any question on this select statement execution? All understood? Can I move to the demo?
Yes.
Okay. Yeah. So we'll move to the demo now. I'll get the server. Okay. Okay. So here you go. My server. Okay. SQL plus slash s. So before you connect to the database, how do you check your background processor running and database instance is running on ps-ef grep
Or
pmon? Pmon you can check one of the background process pmon, right? You can simply check whether pmon is running or not, or you can simply check all, sorry, all oracle processor processes are running or not, all oracle background processes are running or not. You can check here. Okay. Okay, it shows all the background processes, which means your instance is up. Let's connect to the instance now. Yeah, I've connected to the instance. Okay. Okay, I've connected the instance, but whether your database is running or not, how do you check? How do you check your database is running or not? Select name, comma, open underscore mode from v dollar database.
database.
Okay. Okay, my database is rewrite. My database is open and in a read write state, so I can connect and perform all my queries or requests to it. Okay. Okay. Let's see what will happen now. Um, so now I wanted to execute select star from employees. I wanted to see whatever information is select star from employees is having. So we have created this table employees when we are having last session. So let's look at what data it has. So before I go ahead and execute that query, let's see what is the current information in the library cache. So to check the library cache, the query so data dictionary table we have is v dollar sql. Okay, so now let's see. Select. Okay, select sql underscore text, comma, plan underscore hash underscore, sorry, not hash underscore value, comma, parse underscore calls loads parse. Okay, so SQL text will show you the actual SQL text, and flash hash value. I told you, right? A hash value will be generated, and parse calls, whether it is parsed or not. Okay, loads, how many times this query is loaded. Okay, and what is this parse underscore calls minus loads. Okay, whether it is soft parsing or hard parsing, we can check. Okay, so how many times soft parsing is happening, how many times hard parsing is happening, we can check that also. Okay, execution from v dollar sql, where sql underscore text, like, so select star from, employee. Okay, so let's check. Okay, what is this execution? Spelling mistake. Yeah, so it does syntax check. Okay, so what it did, it does a syntax check. So let's rewrite the same query and execute now. So now you see no rows are selected in the library cache. You have not fired any query till date with the select star from employees. Okay, so now let's see selecting the information. Okay, this information is fetched from the library cache. Okay, so let's start selecting the select star from employees. Okay, I have the data available now. Okay, just ensuring set lines 200. I have some data is available. Employee name, employee ID, first name, last name, email, high date, salary, etc. Okay, so now let's see the same query. So whether this information now being registered in the library cache or not. Okay, yes, you see, right? SQL text is available. Select star from employees is the SQL text. uh, I will just put it in a better way. Format E100. Okay, so I'll show you when next time is executed. Now you can see, so soft parsing is not done. For the first time you're doing it, loading happened, so it creates execution plan for this. And this is the hash value I was talking about. There's a hash hexadecimal value that has been created for this query. And one time it loaded. Okay, so it goes through the complete parsing and created an execution plan. And it gone through a hard parsing. So now again the same query i'll be I'll be writing. Okay, so I'll be executing select star from employees. So now what will happen? Okay, now you're seeing the right format data, right? Because I have set the column. Okay, so now you can see what will happening in the. So now you can see the query SQL star from employees, plan hash value, parse calls twos. Okay, second time it goes through the parsing, but it is a soft parse. You can see soft parse is one. Now we are not doing a hard parsing because the execution plan is already there. When it is loading, it is creating an execution plan. Okay, when it is loading, it is creating an execution plan. And now the particular SQL statement have the plan hash value. You can see this value and this value matches. Okay, then it goes to the uh, soft parsing and it goes to the execution. You can see how many times we have executed this particular query, how many times this execution is done. That information also be stored in the library cache. Okay, able to get this? So library cache clear, right? How you can see hard parse, soft parse and everything. Any questions now? And the same thing we can check, like after the parsing, what will happen? It will go to the execution right after the execution plan is created. The server process uh, takes the best execution plan and executes. So what will happen? It goes to the first buffer cache. Okay, whenever your server process hits the buffer cache for the information, if the information is available, that we call as buffer hit. Okay, if the information is available, that we call as buffer hit. Okay, so which will improve the performance. If more hits in the buffer hits, then your database server is performing really good. So your data is available in the buffer cache. Every time it goes to the buffer cache and reads the data, so it need not to work on the additional IO to read the database information from the data files and go back and put that data information in the buffer cache. So if you have a more buffer hits, then your performance is good. If you have a buffer miss, which whenever you go ahead and look at the database buffer cache, you do not find an information there, the block information you don't find, then it goes back to the uh, disk. Okay, so that we call it as buffer miss. Okay, if you have more buffer miss, then which means your server is working more to, get the database information from the data files and putting that information back in the buffer pool, and from there it get back to the user. So that process takes a lot of time, right? Which means it is struggling to get the data and do the process. So sometimes during that phases, performance will be low. Okay, buffer cache is very important. At the same time, shared pool also important for you to have a better performance of your Oracle database. Okay, you can tune all these parameters. Okay, for your better database performance. Okay, so next I'm talking about the buffer cache, right? How it reads or see the information, how we can see the information in the buffer cache. So let's fire a query. So disk reads also we can see. Okay, so you can select SQL test, disk reads, parse calls, loads, parse calls and minus loads, soft parsing execution from $SQL, where SQL text like SQL star from select star from employees. For this query, how the disk reads are there now. You can see. So disk reads are there 2, parse calls are 2, loads 1, soft parsing is 1, execution is 1. Okay, so when you execute this query again, and what will happen, it will go to this soft parsing only. Okay, now the soft parsing will change 1 to 2. You see, so again the same query executed, then it goes through the soft parsing, and you can see disk reads only 2. Okay, because it is available in the 2 blocks it read from the disk. 2 means, okay, now it is available in the buffer cache. It need not to go to the disk. It directly go to the buffer cache and read the data and gets it to the output. Okay, so let's see also buffer gets. From the buffer, now you see disk read, right? From a buffer, how many gets happen also we can see. Just add buffer underscore gets column. Okay, you can see how many times we read from the buffer also, you can see. Okay, you can see buffer gets 84 now. Okay, now I will again uh, do the select star from employees. The buffer gets will change now 86. Another 2 buffer gets we have done, because we have executed the same query. It hits the buffer cache and gets the data, so the buffer gets will increase. Are you guys clear in this demo? Any questions? Pride, Carl, Justin, are you guys there?
Yeah. Yeah. No questions.
Okay.
Can you also share the script also?
Yeah, I will share that. Yeah.
Okay.
Yeah, it's just a normal query only. If you know this $SQL, you can write down this query. You can just simply, to know what are the columns this $SQL have, you can simply write
Mhm.
describe this $SQL. Okay, you will get all the
Oh,
columns. You can choose what of the column, and you can write this query with the where clauses and whatever the information you wanted to get out of this particular $SQL. So $SQL is very relevant to the library cache. Okay, so many columns are there. You can choose what column you wanted. Good.
Yeah.
All right. Shall we move to the next update transaction?
Yes.
So we are done with the select, and now we will go to the another example, update. Okay. So in this case, we are updating employee salary. Okay. Set salary is equal to salary plus 1000. Existing salary, we are adding 1000 extra, where employee ID is 101. Okay. So for the employee ID 101, we are adding salary of 1000. So what will happen with this DML operation? So again, the same, the initial process is same. It creates a user process, and from user process, it connects to the dedicated uh, dedicated server process, and then a session is created, and the PGA is allocated to the dedicated server process. Till this point, it is everything the same, and now it comes. Okay. Okay, it'll check back to the shade pool, like for syntax, semantic, all this information it'll check. Okay, and then since it is an update operation, so it will first check the database buffer cache. Okay, so database buffer cache, it will check whether that particular data is available to update or not, particular block information is available or not to update. Okay, so the database buffer cache, if that has, it will go ahead and update in that particular database buffer cache. Okay, if the blocks are available, the required database information blocks are available in the database buffer cache, the server process will do the modification within that database buffer cache itself. Okay, if not, what will happen? If not, the server process will go back to the database file and reads the blocks and gets those blocks, so back to the database buffer cache. Okay, so if the blocks are not there, it will get those blocks to the database buffer cache. Okay, and those blocks are pinned, which means you are using those blocks to process your transaction. Okay, so that is a state of that particular blocks, these three blocks state currently. Okay, so now what will happen? Okay, you got certain blocks from data files to the database buffer cache, and you kept them, those informations, in the database buffer cache. So now what will happen is, the next stage is the server process will try to modify the blocks that are available in the buffer cache that you have brought from your data file. Okay, so now the server process modifies them. Okay, your update query modifies the salary, right? So that modification is done. You can see red. Okay, they turned into red, so which means they are modified. Okay, in the buffer cache, the current state of the data block is dirty block. Okay, which means a modification happened, but those modified data blocks did not, those modified data blocks were not written into the data file. Okay, so far we have not written those data blocks to the data file. That's why that current state of the data block is become a dirty block. Okay, so you cannot remove dirty blocks until unless you move that particular dirty blocks to our data file. Okay, so what will happen next? These dirty blocks are there right now, the updated information immediately. Okay, the server process moves this information from database buffer cache to the redo log buffer. Okay, the updated information, the changes, okay, information will be moved to the database log buffer, redo log buffer. Okay, redo log buffer will have the updated information. So then uh, so before updated information, it will have a backup copy also, right? like previous information. So that information will be kept it in the rollback segments, rollback or undo. Okay, so this rollback or undo will be used it for the rollback process. So the old information. So before you modify, you will have a old information, right? So that information will be stored in the rollback segments. Okay, so rollback segments, you will have a old information, and redo log buffer, you will have a new information. Okay, so again, what will happen? Redo log buffer also will have the old information too. Okay, it's a change vector, right? So both previous data and current updated data both will have in the redo log buffer. It will take get that old information from the rollback segment and keep it in the redo log buffer. Okay, so here you see a additional component, rollback segment. So rollback segment is used for the rollbacking purpose. Okay, when there is an uncommitted transaction. Okay, when there is an uncommitted transaction you're running and you wanted to roll back, you can use this rollback segments to do that particular operation. If you are committing the transaction, then it goes to the redo log, and redo log file will be going to the redo log online redo log files first. Okay, we'll talk about that. So now you have both information, right? Change vector before the changes to those blocks, what information it has, and after the changes to the block, what information it has. So the next step is it will provide you a row updated. Okay, it will update a client that the status row is updated. Okay, so row is updated, but you have not committed this. Okay, you have not committed this. So then you executed a commit. Okay, your client is executed a commit now. So what will happen when you execute a commit? The redo log buffer information will be written to the online redo log file. First, the redo log buffer information will be written to the online redo log file. Okay, you see it, right? So both change vector information is updated in the redo log file. Okay, first it does update the redo log file. Okay, then it will update the data file. Okay, so then it will show you immediately a commit is successful, which means like you have stored the information in the disk, permanent storage. So your data is secured now. Okay, your data is secured. So now you will get a confirmation immediately. It states that your commit is successful. Okay, then what will happen is the dirty buffers will be moved to the database files with the help of database writer. Okay, so when you execute a commit, sorry, when you execute a commit, what will happen? It first updates the online redo log file from the redo log buffer to online redo log file with the log writer help. Then those dirty buffers in the database buffer cache will be moved to the database with the help of database writer. Okay, so this is how your data will be updated in your buffer cache and database data file. Okay, this is how entire your update query will be executed, and each and every component behaves while you are executing and process that particular information and changes the information in the table. Okay, let's execute this the same query. Okay, update employee query is there, right? Let's execute it in our database. Okay, one row is updated. You guys see the first response I received immediately, one row is updated. Okay, when it will come, one row updated update. Yes, when you update the information, when it moves to the redo log buffer, immediately it says one row is updated. Okay, so now my row is updated, but I have not committed, which means I have not stored this information permanently, whatever update I have made. So now I will give the commit. I'm given a commit command. Okay, so commit completed. So immediately I receive a commit completed status here. Okay, how it came? Because the redo log buffer information is written in the redo log file. Okay, when I've given a commit, it invokes the log writer first. The log writer writes the information from the redo log buffer memory structure to the redo log file, physical file. Okay, then immediately I'll get a response. The commit is successful. Okay, internally it moves the dirty buffers from the database buffer cache to the db writer. Okay, okay, that's it. That's how the transaction update will happen. Now we'll see a select statement on this again. Earlier we have some data, and now what data it will be having. Even you shut down the instance, you shut down the database, again you bring back the database, you will have your data permanently stored in your database. You can see the new data that you have updated. Okay, commit is committed, completed. Now we'll see select star from employees. Okay, so now you see 51,000 because we have added 1,000 extra. Earlier how much it used to be? 50,000. Salary is 50,000 and now it is 50,000. 51,000. 50,000 plus 1,000 we have done update. Are you all clear now? Let me repeat again. Okay, when you execute update query, the step one, what will happen is the connection to the server is established. Okay, pga is allocated, and the statement is sent over to the server. And step two, the server checked the shared pool buffer, shared pool for a pass statement. The statement is passed and put it in the shared SQL area. And then okay, this is a SQL area, and then it checks the database buffer cache. Okay, executes, it checks the database buffer cache, and then the server, if it is available in the buffer cache, it goes back to the data file and reads the information and put back that information in the buffer cache. Okay, and then server process will change the data blocks. Okay, the server makes the changes to the blocks in the database buffer cache, and then change to database buffer cache written to the redo log file. So whatever the changes that happen to the buffer cache will be written to the redo log file, and at the same time the old information in the buffer cache will be written into the rollback segment also, rollback or undo. So this is like uh, used it for the rollback purpose. Okay, so then from the rollback segments, that information will be again written back to the redo log buffer. from redo log buffer, when you process, it'll say that your row updated. When you process a commit command, the information from the redo log buffer will be moved to the online redo log files, physical files. So once the information is stored in the physical files, online redo log files, you will get a update that your commit is successful. Then your updated data, which means a dirty buffers in your database buffer cache, will be moved to the data files with the help of DB writer. DB writer writes the information to the database file, and it stores it permanently, that information in the data files. Okay. So when you commit, right, when you commit, you will immediately get a response from your Oracle database server that commit is successful. That is fast because that happens from the memory itself. Okay, because you have moved the data, and log writer will write the information quickly because the redo log file sizes will be very lesser. Okay, and online redo log files also will be very lesser. It will immediately be written. Okay, immediately be written from redo log buffer to the online redo log files. And this is very important for your performance to have quick commits. Okay, so when you are building a Oracle database server, you try to have your redo log files in a dedicated location. It could be a flash memory, or it could be a permanent storage which have a really good throughput, so that it can, in a flash, it can write the information in the redo log files, and it send back to you the response that commit is successful, which means your transaction is completed. Okay, so then next process is DB writer. DB writer will writes the information to the database file. It can write at any point of time. It can write when a checkpoint happens, when commit is done with the successful. Then it can also write, and there is every 3 minutes it writes the information to the database file, all the dirty blocks that will be written back. So once the dirty blocks are written back to the database file, so those dirty blocks will be change that state of clean, which means so that data is already written to the data files. It will have a reference, like it will check whether my data is already been written in the data file or not. So once it is written, then it will make that status as uh, clean, which means it can be reused for the newly added data again. Okay, any questions? Is my explanation is clear? Guys, are you there? Guys, can you hear me? Rahul, Carl, Pride, do you guys have any questions? Danish, Justin, Uma. Sai, can you hear me? Are you able to hear me? Okay. Okay. People are not able to unmute. Any issue with the GoToMeeting? I don't know. Try and unmute anyone. I don't have. What happened? Why it is not allowing people to unmute themselves? Keep muted, unmute, send unmute request. I'm sending unmute request. Okay. If you guys have any questions, we can discuss tomorrow also. Uh, Tomorrow we will be starting Linux basics. Okay. We'll have two to three sessions on the Linux fundamentals and Linux basic commands. How we can use those commands in our Oracle database administration. All I will be discussing about. So basically, the file structure. So what is the file system? What are the mount points that Linux system will have, and also permissions. How do you give a permission? How you can create a directory and navigate files and directories in the Linux systems. Create a file and edit a file, and then create some basic shell scripting and executing them. So important files that we need to know about in the Linux server, I'll be discussing, and important commands as well that you need to memorize as a DBA to run those commands while you are working in your day-to-day operations. Yeah, I'm not sure what went wrong with the GoToMeeting. You guys are not able to unmute yourself. Um, but feel free to reach out to me if you have any questions. We will connect and spend some time before we begin tomorrow's session on the question and answers. Yeah, Justin, you unmute yourself. I think you guys are able to unmute. Yeah,
Oh, yeah, yeah.
Yes.
go ahead, go ahead.
Nothing.
Uh, okay.
Yeah, now the it's okay. Hmm.
Something fishy with the tool.
Uh, uh. So Uma is asking a question.
Yeah, go ahead, Uma.
So what if the user didn't commit and
Go ahead. One more time. Uma, are you there?
Yeah, what if the user did not commit instead of
Okay.
if he's do the rollback? Hmm.
Okay, let me see the example. So now we will see one more example. We have executed update statement. Okay, update employee. Okay, set salary equal to salary plus one more thousand. I'm adding. Okay, where employee underscore ID equal to 101. Okay. So now just I'm updating the information of the employee 101 with salary one more thousand plus. So now I have just get an update that row is updated, which means my data blocks were updated and they turned dirty blocks. Okay, so those were the changes already captured by the redo log. Okay, redo log buffer, I would say, not the physical redo log file. Okay, redo log buffer, the changes were kept in the redo log buffer, and rollback segment is also there. Okay, so now what will happen if I do not commit? So this transaction will not be saved permanently. Okay, so this employee ID will not be saved. It's supposed to be 2000, right? 2000 totally 52,000 it should be. Okay, let's see, select query, select star from employees. 52,000. Okay, it is there, but you can do the rollback. Okay, you can do the rollback now because you have not committed. Okay, you can roll back also because your information is available in the undo segments. You simply give a rollback. Okay. So now where I'm typing. Okay. Okay. Your rollback is completed. Now we will see what is happening. What is the select query is having? 51,000. Uma, you're able to get this?
Yes.
Yeah.
How undo segment is managed, like how long it will keep that block for?
Uh, we will talk about this in the undo segments, like table spaces, undo segments. All these concepts will come in the future. Okay.
Okay.
So yeah, we will talk about this specific concept. This will take one session itself. Undo segments, undo management. So a lot of components will come into the picture. Okay. So we'll talk about this
Yeah, thank you.
table space and undo management, rollback segments, all these things. But right now you understand, right, why this undo segments or rollback segment is used for. So you can immediately roll back the update. If you have committed, you cannot roll back because that committed transaction will be written permanently on your redo log files and then your data files also. If you wanted to roll back at that time, you have to go to the point in time. You have to use your change vector information available in the archive log files or redo log files. Am I clear?
Yeah, thank you.
All right. All right. Any other questions from anyone? Okay. I take this silence as no. So let's talk tomorrow about our Linux basics and basic commands from tomorrow onwards. It'll take 2 to 3 sessions. So you'll all get a good hands on the Linux environment as well, because most of the Oracle database runs on the Linux machine only. You need to be really familiarize on the Linux commands and proficient in running those commands to do your regular day-to-day operations and duties as a database administrator, as an Oracle database administrator.
Yep. Okay, Srikant. And we will also share the notes for this architecture and before these architecture sessions, we'll share the
Yes,
notes as
yes,
well.
yes, yes. We'll probably put that information like in the entire documentation in the portal itself.
Yeah.
Yeah. So whoever have an access to the portal, they can get the complete documentation for this architecture.
Mm.
Okay.
Yep. I'll create a page for that,
Yeah, Oracle
Srikant,
page.
for
Yeah, Oracle
portal.
page.
Yeah. So our people can directly log in and they can access there.
Yeah,
I'll
whatever practice we
make
have
it work.
done. Yeah,
Mm.
queries we can put over there.
Yeah. Mm.
Yeah.
Yep.
Okay. Yeah. Thanks everyone. Thanks for joining. Let's catch up again tomorrow. With that, we have completed successfully the architecture part. I'm hoping everybody is clear with the architecture, Oracle architecture. This is very crucial for us to progress our learnings in our upcoming activities, upcoming learnings, installations, or whatever you do, day-to-day operations, management of the Oracle database, etc. It always ties back to the architecture. So you need to be really strong in architecture part. Cool. Thanks everyone. Thanks for joining. We'll catch up again tomorrow.
Thanks.